Hello, this is Ms. DB, and I'm going to talk today about Chapter 5, Section 4 on the slope formula. So the slope formula is a way that we can find the slope of a line, which is very, very important that we do this correctly. And we've already looked at some different aspects of slope. We know that slope can be positive or negative. We know that it's undefined. If you have a vertical line, we say the slope is undefined, and we know that a horizontal line has a slope of 0. And we've already worked with finding the slope of lines from a graph. But now we're going to look at how do you find the slope if you just have 2 points that are on the line. So we have a formula for this, and the formula is that m is equal to, and then there's a fraction, it's a fraction kind of thing, m is equal to y2 minus y1 over x2 minus x1. So that's what's in this box right here, and it's also written here. Now, what is y2 and y1 and x2 and x1? Those come from the points that you're given on the line. For example, let's look at this example here. Let's say that we have a line that has the points 2, -3 on the line and 1, 4. So you could sketch this. You could draw a coordinate system, and you could say, well, I'm going to put the point x is 2, y is -3. I could put that on there. And I could put the point 1, 4. And then I could draw a line between them. I'm drawing freehand here, so my line's going to be a little bit wobbly, drawing with this tool. But, you know, there's a really wobbly line. So obviously it's not a great method. You could also use Sketchpad or an online graphing program or a graphing calculator if you have them. And then you could find the slope by doing rise over run. That's an option. You can do that. If you're really good at graphing, maybe on coordinate paper, then you could do that. But the slope formula lets us do it without graphing. So here's what the slope formula means. If we have the point 2, -3, that has an x-coordinate and a y-coordinate. The x-coordinate is always first. This is the first point that I put on my graph, so I'm going to call this x sub 1, y sub 1. Now, the little ones are just subscripted. That's why we say sub. So this point, x sub 1 is equal to 2, and y sub 1 is equal to -3. Those are just values of those variables. Now, I had another point on my graph. I had the point 1, 4. I'm going to call this x sub 2. That's my second point, y sub 2. The 2's just mean it's the second point I graphed. So x sub 2 is 1, and y sub 2 is 4. Now I'm ready to use my formula. Now, you don't always have to write those out like that. You can just see them and say, well, x1, y1, x2, y2. I'm going to make my pen a little thinner here. Okay, now we're going to put them into the equation, the formula. The formula says to use that the slope, we call it slope m, by the way. M is slope. The letter m stands for slope in a linear equation. So m is equal to y sub 2 minus y sub 1. That's the difference of the y values. I need to subtract the y values. And on the bottom, we take x sub 2 minus x sub 1. That's the difference of the x coordinates. So let's see, y sub 2, that's right here. That's 4 minus y sub 1. That's right here. That's -3. I have a minus a negative, so be careful of that. Over x sub 2, here it's 1. And x sub 1 is 2. So now I'm ready to simplify this. I have 4 minus -3. That's the same as 4 plus 3. On the bottom, I have 1 minus 2, which is -1. And now I need to simplify the top, the numerator, and that would be 7. And the bottom is -1. That's the same, 7 over -1 is the same as -7. So my slope, my m of this line, would be -7. So you write your slope as a fraction in simplest form. So you always write your slope as a fraction in the simplest form. If it's over 1, you can just write it then as an integer. So see how, here's another example. In this example, the points were -1, 3. That would be x sub 1, y sub 1. And then the other point was 2, 0. That would be x sub 2, y sub 2. So then they replaced in the formula, which is m equals, right here's the formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. They replaced those values, those variables, with their values. So y sub 2, that's 0. So they put a 0 here. Minus 3, because 3 was y sub 1. So on the top you have 0 minus 3. On the bottom you'd have 2 minus a -1. And then they simplified. 0 minus 3 is -3. On the bottom, 2 minus a -1 is the same as 2 plus 1. So then they got 3 here, you can see. And -3 over 3 is -1. So this time it again simplified. They don't always simplify. Oftentimes you will write your answer as a fraction. You will get a fraction. For example, here's another example. Lots and lots of examples here. In this example, when they did the work, they got an answer of -4/5. Don't change that to a decimal. Just leave it as -4/5. If you get something like -10/20, you could simplify that to -1/2 by dividing both by 10, but don't change it to a decimal. Slopes are best as fractions because they help us graph. So for the next part of your worksheet, you're going to do the same thing we just did. And the first couple ones are started. So you can see that there's already the fractions written. And you're just going to have to simplify in 1 and 2. They already put in the values of x sub 1, y sub 1, and x sub 2, y sub 2. And I'm going to just go ahead and simplify this, and I would get 4 over 4, which is 1. Now, I want to show you something. What if, when I wrote these down, I have the point 5,7 and the point 1,3 on my line. And what if I said that I'm going to call this x1, and this y1, and this x2, and this y2. So notice that it's the same points as from number 1, but this time I called the other point x1, y1, and the other point x2, y2. Do you think we'll get the same slope? Let's find out. So the formula says to take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Always the y values are on top. It is the rule that you're taking the difference in the y values, because that's the rise, over the difference in the x values, which is the run. So y sub 2 is 3, and y sub 1 is 7. So I have 3 minus 7. On the bottom, I take x sub 2, which is 1, minus x sub 1, which is 5. So then I simplify. I would get 3 minus 7 is -4. Oh, I cut off my -4 there. -4 over 1 minus 5 is also -4. So this isn't simplified yet. -4 divided by -4 is 1. And 1 is exactly what I got when I used the points in the other order, that x sub 1, y sub 1 was 1, 3. So it doesn't matter which point you choose to be the first point and which point you choose to use as the second point. You just have to choose one and keep it that way for both the x and the y values. You couldn't flip-flop like this is x sub 1, y sub 2. That wouldn't work. Then you'd mess up it. But you can use either point. So if you think that it'll be easier to use, maybe less negatives or something to do it one way or the other, that's just fine. Okay, let's look at the second part here. This is finding the slope from graphs and tables. And we have looked at this before, but sometimes your points are not already on the line so obviously spelled out for you like this. Let me look at this one they have. In this graph, they did put some points there. Let's pretend they're not there. Let's say we just had a line and it says to find the slope. So what you would do is you would look for places where this line goes right through the crosshairs of the graph. Like here's a point. It goes right through at 1, 3. And then you could look, and I think the only other pairs are going to be the ones that they have marked. I'm going to use the point 6, 5. Now, in general, the points you pick to find the slope, it's a little easier to do the slope formula if your points are positive. So if your coordinates are positive, if you can. Sometimes you have to use negatives, and that's fine too. So for which two ordered pairs are plotted on the graph? There's these, or here's the point that was also on there, but we didn't write down its coordinate, -4, 1. So any of these 3 points would be good to write for number 7. You only have to pick 2 of them. Then it says to find the slope of the line. Well, for the slope of the line, that you use the formula m equals y2, the difference in the y values, over the difference in the x values. Remember, we only need 2 points. We don't need 3. So at this point, you have to go ahead and say, well, I'm going to use, maybe, wow, that's a big fat line. I'm going to use these 2 points. Or maybe I'm going to use the points that were on the graph. So make a decision, pick your points, and then plug them in to the equation. So it says the difference of the y values go on top. Here's a y value, here's a y value. I have to subtract them. You can either go 3 minus 5, or you can go 5 minus 3. Let's go 5 minus 3. Now when I get to the x coordinates, I cannot go 1 minus 6. I have to start with the same point that I started with before. So I'm going to go 6 minus 1. So I use this as my x1, y1, and this is my x2, y2. I don't really have to write that out, but it might help me say, okay, yeah, I went 5 minus 3, yep, that's right. And then I went 6 minus 1. And then you just simplify. 5 minus 3 is 2. 6 minus 1 is 5. And you should check and make sure that your slope matches your line. Yeah, it's positive, and I got a positive answer. And it cannot be simplified anymore, so then that's it, you're done. Now you could also find the slope of this one, because there is a graph for it, by sketching out a slope triangle. You would go straight across and then straight up, and then the rise is 1, 2, and the run is 1, 2, 3, 4, 5. So there you go. All right, let's see what else is on this worksheet. From a table, let's look at this. If you are going to find the slope of a line and the points are all in a table, you just pick 2 of these. Maybe I'll pick the first one and the last one. It doesn't really matter. You can pick any points, any 2 points. So I'm going to say that my x1, y1 is the 4, -5. And I'm going to say that x2, y2 is 16, 1. Now you might choose to pick 2 different points. Everybody, no matter which 2 points of this table they use, should get the same slope. Otherwise, there's a mistake. So the formula, again, is that the slope is equal to the difference in the y coordinates, y2 minus y1, over the difference in the x coordinates. Now we just have to plug them in. So y2 is 1, right here. y1 is -5. Watch out for those minus negatives. And then x2 is 16. And x1 is 4. So on the top you'll get 1 minus -5, which is the same as 1 plus 5. On the bottom you'll get 16 minus 4, which is 12. So you're going to get a fraction that can be simplified. 6/12 can be written as a simpler fraction, so you should still do that, simplify, and you should get 1/2 as an answer. Let's see, what else is on this worksheet? The last part is on an application problem. We can find the slope of real world situations, just like other ones. The only difference might be that the numbers might be bigger. And then you should also be able to kind of explain what the slope means. So you might need to read the information that's in the graph. For example, in this example, it says that this is the water in a reservoir, which is like a big holding tank for the city to use. And the water in 1,000 cubic feet is along the side. This is how many cubic feet of water they have. And this is the time in hours. So this is over, looks like several days, because 60 hours is more than 1 day. So at 0 hours, the water is way up here at, that must be 3,500. And then every day it's going down, or every hour it goes down. At 20 hours, there's 3,000 cubic feet. And at 60 hours, there's 2,000 cubic feet. So you're going to find the slope by subtracting the y values over the difference in the x values. So they found the slope is negative 25, or negative 25 over 1. Now what does that mean? That means that this is over 1 really, it means that every hour this water in the reservoir is decreasing by 25,000 cubic feet each hour. Because it's not just 25 cubic feet per hour, because this is in thousands. So 25,000 cubic feet each hour, it's decreasing by that much. If it's a positive slope, then it's increasing. So you have 2 problems to do. They're both increasing. And then to tell what the slope means after you find it, in this one, it's temperatures Fahrenheit along the bottom and temperatures Celsius. So your slope is going to mean something along the lines of, for every Celsius temperature is equal to this much Fahrenheit temperature. And the second one is money earned and time worked. So this is going to be, you know, this is how much money you earn per hour is what you're going to figure out by your slope. You'll be able to figure out this person's hourly rate. And then there's just one problem at the end where you have to figure out who made a mistake and say that, and then fix their mistake or explain what they did wrong, one or the other. All right, so I hope that you have a good time doing this slope worksheet, and make sure that you're doing it correctly, because it's very important, and you'll continue finding slopes of linear equations for a long, long time to come. Thanks a lot and have a wonderful day.